All right, here's a good one because we're going to create an amine group. And at this point in organic chemistry, we don't know a lot of different ways to do that. But we do know that we can use good old oxymercuration, demercuration in order to accomplish that. Usually we see oxymercuration, demercuration create an alcohol, but really there's a nucleophile here. And generally, if I want to make an alcohol, then that nucleophile is water. If I want to make an ether, then that nucleophile is alcohol. But if I want to make an amine, then I can do that if I use an ammonia-based nucleophile. And so that's what I'll do. It's still going to be Markovnikov in its addition, but this is the reaction that I'm going to take advantage of here in this first step. Well, in the last step, since we're thinking backwards. Now, the question is was there a double bond here, or was there a double bond there? And I think if we try to continue to use some advice that we want to try to use the most efficient reaction, then we realize that if we had a double bond at the location of the red bond, then that's not going to be as efficient because we would actually be able to, that Markovnikov position would be equivalent on either side of the double bond. So we would end up adding this amine group, but we would also add an amine group there. So let's try to have a more efficient route that involves having a double bond at the end, because now with this oxymercuration, demercuration, we know that we're going to get all of our product will be the product that we're looking for. All right, well, what's next? Well, I'm at an amine group, or I'm at an alkene, and so I have to think about how I can make an alkene. It might be a good time now to think about 7 versus 9 carbons. So I'm going to have to add some carbons to this structure. And so the fact that I'm going to add some carbons to this structure might help me pick which choice I have. Remember, I can do elimination, or I can do or I can do a reduction to get an alkene. If I did elimination, then I would have to have some leaving groups, either in this location or in that location. And if I think back one step, well, how did I get a leaving group on there? Well, then I'd have to do an addition reaction, which means that I'd either have to have a double bond in this place or a double bond in this place. And so I think what we want to do at this point is to say to ourselves, well, we can explore that path later, but I think it's not going to be the right path, because ultimately I still need to add a carbon, or I need to add 2 carbons to this structure. And because I'm adding 2 carbons to the structure, I'm going to have an alkyne. Remember, the only way we can add carbons is right now in this part of organic chemistry is through alkylation, which yields us alkynes. And so that's going to kind of give me the idea that maybe I want to try reduction instead of elimination to make this alkene. And so that would kind of take care of a lot of things for us. If I start out with an alkene or an alkyne, then I've got my 7 carbons. Now I have to use a poison catalyst. It doesn't matter which one because it's the stereo, there's no stereochemistry, but I do have my extra 2 carbons. And that is fairly straightforward in the sense that if I were to have this structure, then I could add this alkanide ion in order to make this reaction happen. Now I'd still need to protonate it, so I'd need 2 steps. Okay, but how do I get this bromine on here? Well, I could get a bromine on there if I had a double bond here. We could do that with HBr and ROOR. And I think we're getting closer, because if I had a bromine here, then I could eliminate it with tertiary butoxide to get the Hofmann product. And because this is a tertiary position, I can add Br2 to an alkane with radical bromination. So this one was a pretty complicated set of reactions. We're starting to get examples of synthesis problems that are going to be about as complicated as they get in Orgo 1. But one of the things that should be illustrated at this point is that you do have to know all of the reactions from the entirety of the course in order to take a full advantage of being able to solve all of these different synthesis problems. So 1, Br2 and HNu, 2, potassium tertiary butoxide, 3, anti-Markovnikov hydrohalogenation, 2 or 4 would be alkylation, reprotonation of the alkanide ion, reduction with a poisoned catalyst, then finally oxymercuration, demercuration with the ammonia nucleophile. Okay, this is the whole set of synthesis. It's a lot of different reactions. It's 8 steps, but we are getting a lot of different reactions together. This one was from the chapter on radicals. This was from the chapter that involved eliminations and substitutions. This one was from the chapter on addition reactions to alkanes. This one was the chapter that involved alkynes. These go together. This one was also alkynes. And this was a little bit more obscure reaction from the alkene chapter, the addition reactions to alkenes. Okay,